All right, so we're talking about lines that are perpendicular. Perpendicularity is what it's called. And it says lines, segments, or rays that intersect at what we at four right. I'm just kidding. I think I'm gonna fill that in later. At right angles. Sorry.
Oh, you're gonna do another paper after you finish?
No, we're just finishing the back. Okay, so lines, segments, or rays that intersect at right angles are perpendicular. Yeah, I don't have enough room to write that. I need to write smaller. Perpendicular. 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 And there is an abbreviation for perpendicular. It's like an upside down T. Okay, if you see that. Yeah, if you know what it means. Okay, that upside down T means perpendicular. So you're going to be told that lines are perpendicular, and most of the time they're going to use that symbol for you. Okay, so you just need to make sure you know what that is. All right, so again, lines, segments, or rays that intersect at right angles are perpendicular. Segments or rays can be perpendicular to lines or other lines, segments, and rays. And the right angle symbol indicates that the lines are perpendicular. So if you look in your picture, do you see those little boxes in the corners there? Right up by E, there's two boxes. Do you guys see that on your picture? That means right angles. So if you have a right angle mark, then that tells you that those two lines are perpendicular. So in that picture, line AC and line DB are perpendicular. Perpendicular lines intersect to form four right angles. And then perpendicular lines intersect to form congruent adjacent angles. Okay, so if I were to draw any two lines, and I put that one little box there, that tells me that all four of these are right angles and that these lines are perpendicular to each other. Does that make sense? Now, if I did not have that box, you cannot assume that they're perpendicular, okay? In geometry, bless you, things are not always drawn the way they're supposed to, so unless they specifically tell you that the lines are perpendicular or that they have the box there, that's the only time you can say that they are actually perpendicular. Does that make sense? Okay. All right, so let's look at our example over here, and I'm going to have to blow it up because I can't see that. It says, find the values of x and y such that PR and QS are perpendicular. And if it's okay with you, I'm going to redraw that up here so I can actually see it and write on it. Just a second, I can't see all that. Okay, is everybody? That's the picture you have on your paper? Mm-hmm. It's just easier for me to see it up here. Okay, so it says we're going to find the values of x and y such that PR and QS are perpendicular. Okay, PR and QS. So they want them to be perpendicular, which means that should be a right angle, correct? And then this also should be a right angle. Okay. So let's start with the y. There's only one angle that's labeled with the y, correct? What do you know about that angle based off of what they want us to say? They want us to say they're perpendicular. So what do we know about this angle that's marked as 4y minus 2? It's equal to 90 degrees. So in order to solve for y, we're just going to take that 4y minus 2, and we're going to set it equal to 90. Okay? They want them to be perpendicular, which means they're going to form right angles. And so if I want to solve that, 4y minus 2 equals 90. I'm going to start by adding 2. And that's going to give me 4y equals 92. And then we will divide both sides by 4. Is it 23? Are you okay with that one? Okay. Now, the x's, how many angles up there have a label with an x in it? 2 of them. And if we look at, are each one of them equal to 90? No. What would you say, though? What are both of them together? What are they equal to? They're equal to 90, right? Because this angle plus that angle is going to be that right angle that we have marked here. So what equation would I set up? I would say 5x plus 6 plus 2x. I need to add the other angle, and that's going to equal 90. Okay, the two angles, the two small angles together, this one and this one, together added equal that 90 degrees because those lines are perpendicular. So I want to solve this equation. I've got x's on both sides of, on the same side of my equation. So I'm going to add those together. Try that one more. And then I'm going to subtract my 6 over. And then I'm going to divide by 7. For x. So x has to be 12 and y has to be 23 if those lines are going to be perpendicular. So let's go somewhere else while I'm doing this. We should have our phones on the desk, sorry. Anybody have any questions? Okay, so let's read through what this says about interpreting these diagrams. It says points of intersection can be assumed. You can see where things intersect. Therefore, you can identify vertical angles from the figure. Linear pairs also can be assumed. Therefore, we can apply the known characteristics of a linear pair. Which is what? A linear pair adds up to be how much? 180. We form a line, that's 180 degrees. So linear pairs can always add together to equal 180, which is what that says. It says such as supplementary angles. And if we're looking at our picture, it tells me that angle ABD, okay, ABD, that's this top angle up here, and angle CBE are vertical angles. What do you know about vertical angles? They are congruent, okay? So angle ABD and angle CBE are vertical angles, which means they are congruent. That means they have the same measure. And then it says angle EBA. Let me erase my markings. Angle EBA, which is this angle here, and angle ABD, which is this angle here, are a linear pair. Do you see how they form that straight line right here? Yeah. So we could add those two and set them equal to 180. And that's just based off of looking at a picture. Okay, I talked a few minutes ago about you can't assume certain things. You can always assume vertical angles, and you can always assume linear pairs. You can't, however, assume perpendicular lines unless you're given some information. And so just be careful with what we're assuming here.
So what we typically on last time, it needs to be all on the test. It's trying to be added together.
Mm-hmm. Yep, everything together. All right, so what I want you to do is we're going to go through these piece by piece. I want you to take just a minute. I want you to look at that figure. We got a lot of things going on over there. Letter A says that CE and CF are opposite rays. Can we assume that from the picture? It's just going to be a yes or no answer. Remember, opposite rays share an endpoint. They go in opposite directions to form a straight line. So looking at your picture, find ray CD. CE and CF, and tell me Are they opposite rays? Do they share an endpoint and do they go in opposite directions, forming a straight line? Okay, let's look at it. I'm going to highlight it up on the TV. CE starts at C and goes through E. Okay, that goes that way. And then CF goes that way. Do they form a straight line together? Yes. So are they opposite rays? Yes. Then I want you to look at the next question. Look at your figure. Determine if you can say yes or no. Can they be assumed? Yes or no. Angle BGC, find that angle. And angle KGC, do they form a linear pair? Angle BGC, look at your picture. And angle KGC, do they form a linear pair? Remember, a linear pair has to be adjacent. They have to be next to each other. And then they have to make a straight line giving you 180 degrees. Okay. Let's see, angle BCG is this angle right here. And angle KGC is that angle. Do they give me a straight line? Are they adjacent and form a linear pair? Yes. Okay, try the next one. Angle ABJ and angle CBG are vertical angles.
No.
Angle ABJ and angle CBG are vertical angles. You say no? Let's see.
So it's back-to-back yeses, so it can't be another yes.
ABJ is right there, correct?
Mm-hmm.
All right. CBG is here. Ooh. Are they vertical angles?
Mm-hmm.
Yeah, they're formed by two intersecting lines.
3 yeses?
Yeah, 3 yeses.
That means the next one gotta be off.
So that means this angle ABJ and CBG, those are going to be congruent because they are vertical angles. So yes. All right, the next one. Can we assume from the picture that angle BCG, okay, I had to find that angle, sorry. BCG and DCF, BCG and DCF, can we assume that they are congruent? The only way that we could assume they are congruent is if they are vertical angles. So you got to look at your picture and decide BCG and DCF. The only way they could be congruent at this point is if they are vertical angles. What do you think? Now, let's see. BCG, that's that one. And DCF. They're not made from two lines, are they? They're not directly across from each other? Okay. So, no, we cannot assume that they are congruent. They might be, but based off of just the picture, I cannot assume that. Okay, the next one says that line segment BE and line IF are perpendicular. Can we assume that they are perpendicular?
No.
Okay, remember the picture I drew up here earlier. We can only assume that they are perpendicular if we have what kind of marking there? A little right angle mark? Do we have any right angle marks in our picture? No, so let's take a look at it again. It looks like they might be. Here's BE, hold on. Here's BE, and then IF. It looks like they might be. However, I don't have enough information to say that they are because I don't have any right angle markings in my picture. So I'm going to have to say no. All right. Angle EBC and angle GBC are complementary angles. The only way we know they're complementary is if we know they add up to be 90 degrees together. Kind of goes along with that last question. Do we have any right angle markings in our picture at all? No. So would I be able to say that any angles are complementary? No. They might look like they are, but I don't have enough information to say that they are. All right, angle ICH and angle HCD are adjacent angles. They share a side and they share a vertex. That's what adjacent means. They share a side and they share a vertex. ICH and HCD. Okay, let's look at it. ICH, find that, ICH, and then HCD. Do they share a side and a vertex? They do, don't they? So are they adjacent? Yes. And then the last one says that segment BC, or is that a ray? I can't see that. Segment BC is an angle bisector of angle ECG. What does an angle bisector mean? That it cuts an angle in half. Do we have any congruent angle markings in that picture? No. So can we assume that segment BC is a bisector of angle ECG? No. Okay. Don't have the markings. Cannot assume it. Even if they look to be the same size. I don't know because I don't have enough information. You have to be careful here. Okay, a lot of times people assume things because it looks like it, but unless you're told that it is, it cannot be assumed. Everybody okay with that? Okay. All right, looking at your picture. I want to know angle 1 and what other angle are complementary. That means they add up to be 90 degrees. How do you know that? Because you have that little right angle marking right up here. Whoops. Sorry. We have this little right angle right here, which does tell me that 1 plus 2 is going to give me 90 degrees. So angle 2 is the answer for that. Okay, what does complementary mean again? They add up to be? No, that's congruent. 90. It starts with the same letter, so don't get them confused. That is an issue sometimes. Complementary adds up to be 90. Okay. What about supplementary? Those add up to be 180. So angle 5, and what other angle is supplementary? Which other angle with 5 adds up to be 180 degrees?
6.
Angle 6, yes, because they form a straight line, linear pair. Exactly. All right, next, are angle 1 and angle 2 a linear pair? Linear pair has to be adjacent and form a straight line. Are angle 1 and angle 2 adjacent, first of all? Yes, they are, right? They're next to each other. But do they form a straight line together? No, they do not. So they are not a linear pair. Okay, how are the vertical and horizontal lines related? Let me highlight those. Vertical means which way? Up and down. Horizontal means side to side. So we're talking about those two highlighted lines right here. The vertical line and the horizontal line. How are they related? What can you tell based off of the marking in the picture? I heard somebody say that. They are perpendicular. How do you know it's perpendicular? Because of what marking? The right angle marking, exactly. You have that little right angle marking in the corner, which means that those two lines are perpendicular. Sorry. And then I want you to take a minute and let's talk about number 5. If the measure of angle 2 is 27 degrees, I'm going to fill that in, okay? If this is 27 degrees and angle 3 is 59 degrees, it wants me to find out what is the measure of angle 1, 4, and 5. Okay, 1, 4, and 5. Let's start with 1. What did we say earlier about angle 1 and angle 2? Look back at question 1. What did we say angle 1 and angle 2 are? Complementary are equal to 90. So if angle 2 is 27 degrees, then to find the measure of angle 1, I'm going to go 90 minus 27, which is going to give me 63. So look at your picture. If angle 1 and angle 2 are complementary, what would you tell me about angle 3 and angle 4? They would be 90, yes. Angle 3 and angle 4 would be 90. There's a couple of different ways we can actually do this question. We can use the 180 as well. Let me show you. So we figured this one was 63. This one they told us was 27. This one they told us was 59. Okay, and then we have that, right? Which means this is a right angle, this is a right angle, and so is that, correct? Okay. So we can do one of two things. We can do, to find the measure of angle 4, we can either do 90 minus 59, or, let me ask you a question. What do all 4 of these together give me? 180. They give us 180. So we can also do 180 minus 63 minus 27 minus 59. Okay, so you can actually do it one of two ways. Either one of those, it doesn't matter. The easier one is doing it from the 90, right? Unless we have a calculator handy, but let's see, what's that going to be? 31? So we know that's 31 degrees. Now, let me ask you a question. They also want us to find angle 5. That's this angle right here. What is that? Somebody said it. 90. Okay. Because if that's a right angle, all 4 of these are going to be right angles, which means angle 5 would be, which would be, angle 6 would also be what? 90 degrees. Okay. So a lot of these, you can use one of two things. If you have complementary angles, you subtract from 90. If they all together make a straight line, then you can use 180. But you cannot assume things are perpendicular unless we have our little right angle markings. What do they say? These lines are perpendicular. Anybody have any questions? Like the first part of it? Right there?